1.7, represent functions as graphs. So we can represent information given to us in a few different ways. So if we had a table with input-output values of inputs of 1, 2, and 4, output 2, 3, and 5. Then from that, we can make ordered pairs that I can graph. So input values, remember, are x values, output are y values. So I can make these ordered pairs. And that is from input being the x, output being the y. So I have the point 1, 2, the point 2, 3, and the point 4, 5.
Bless you. Bless you.
Bless you. Then from there, I can take that information and I can graph the points. I set up my axis. You're welcome to use graph paper if you want, but you do not have to. But you need to have labels on stuff. So then at this point, yes.
Can we write it like 1, 2, 3 or something, or do I have to put it in like that, like intervals of 2?
Oh, I don't care. I just was putting a few on there to know. I'm technically doing intervals of 1. I'm just only writing the even ones. I don't really know why I did that. I just did it. As long as they're labeled so I can clearly tell like what your spacing is, that's really what I care about. So now I'm going to plot these points on my graph. So the point 1, 2, we're at 1 on the x and up to 2 on the y. So it's there. The second point is 2, 3, so that's 2 on the x, 3 on the y. And my last point is 4, 5, so 4 on the x and all the way up to 5y. So those are my 3 points that I am plotting there for that graph. So just for the sake of us looking at it, this is our input values or our x. This is output or y. So sometimes they may give you something that says just to graph the function, and they give you like y equals in an equation, and then they tell you the domain values, which are which values? X or y?
X.
X. So those are my x values. So then I would take and plug those in and get x, y values, and then I can graph them. So if you had something like graph the function y equals 2x minus 1 with domain 1, 2, 3, 4, and 5. What I'm going to do is I'm going to make a table. So the domain values are my x values. So 1, 2, 3, 4, and 5. And then I'm going to plug in these values for that. So when I plug in 1 for x, what do I get for y? 2 times 1 is
1.
2 minus 1 is,
1.
okay, so that's the 0.11. Plug in 2 for x, what do I get?
3.
3.
Plug in 3 for x, what do I get?
5.
Plug in 4 for x, what do I get?
7.
Plug in 5 for x, what do I get?
9.
Now, the nice thing about the way I wrote the table and the fact that I wrote it like going up and down like this is this automatically kind of makes your ordered pairs for you, right? And you don't have to rewrite them as ordered pairs. It doesn't ask us for that. It just says to graph with the domain. So you either need to set it up as ordered pairs or you need to make a table. I don't really care which one you do, but just for the visual. So my graph, and all these numbers are positive. That's why I'm just doing like quadrant 1 of a graph. If we had negative numbers, obviously I would have to do the whole thing. But my x values, I need to go out to 5. Y values, I need to go up to 9. So I'm going to label increments of 1 down here on the x. But on the y, I'm going all the way up to 9. So you can either count increments of 1, and you can be like, all right, that's 1, 2, 3, 4, and so on and so forth. Or you can spread them out a little bit if you want to and do like 2, 4, 6, 8, 10. Okay, I don't really care how you do it. Either way is fine with me as long as you have it labeled. So the first point is at 1, 1. So 1, 1 is there. The next point is at 2, 3. So 2 on the x, 3 on the y. The next point is 3, 5. So 3 on the x, 5 on the y. 4, 7. I'm at 4 on the x, 7 on the y. And then lastly, 5, 9. So 5 on the x, 9 on the y is up here. And you're just plotting the points. Don't connect the dots. All right, if we have something like that says to write a rule for a function, so it's kind of like working backwards. They're going to give us the graph and we're going to work backwards. So doing the opposite of what we just did in the last one. Write a rule for the function represented by the graph. And then it says to identify domain and range, which remember is our input and output values. And then they give us, just so it's easier to see, I'm going to put some grid lines up really fast. So they give us a graph to start with. It's 5 on the y and out to 6 on the x. This is going to be really big, but... So then, I made this way too big. Just pretend that I didn't do that. So went out to 6 on the x, and then on the y up to 5. Then the points that they give us, got one here, one there. So that's what it looks like with what they gave me. So my recommendation is to make a table of the input-output values that are given to you so that we can ultimately write our equation. So I'm going to do input, output, so what's my first point?
1.
5.
0 and 5.
0, 5, so 0 on the x, 5 on the y. So that's the first one. What about the second one?
1 and 4.
1 and 4. Third one?
2 and 3.
2 and 3. Fourth one?
3 and 2.
And 2.
And last one?
4 and 1.
So there's my table. So now I need to figure out what equation I can write to explain this. So up here, notice we started with an equation and they gave us our input domain values and then we found the y values. So we're working backwards. We have the table. So I need to figure out an equation that will work for that. So what I do is, especially since there's a 0 that's been used, that makes it even easier. Okay, because when x is 0, what do we know about y?
That's multiplying.
We know that when x is 0, y is 5, right?
Y minus X.
Do we see that? When x value is 0, y is 5. We see that, right?
Yes.
Okay. So that tells me that to start with, y equals 5. There's no x there, meaning x is 0. Okay? Now, what happens when I go to x being 1? What is y?
4.
So how do I get from 5 to 4?
You subtract 1.
Subtract 1, okay, which is subtracting whatever my x value is, right?
Yeah.
So when you write this, plug a number in and check it. So let's plug in 3, okay? So y equals 5 minus 3, which is
2.
a point down here. So I can check it that way. So obviously these ones are a little harder, but you should be able to check the equation that you get. If you can't figure out the equation or you get stuck, put a little note on there and be like, I'm not getting the equation right because I'm checking it and it's not coming out right if you can't for some reason figure out what it is. Okay, show me that you're trying to figure it out, but I understand that some of them are going to be confusing and a lot harder to do. Okay. Let's look at some examples out of the homework now. It's a really short section in terms of problems. So, number 4, these just say to graph the function. So this is going to look like this example here. They're going to give us an equation, some domain values, and then they want us to do the table and ultimately the graph to do that. So number 4, y equals 1/2 x plus 1, and the domain values are 0, 1, 2, 3, 4, and 5. Also, we forgot to do domain and range on this previous problem. What are my domain values from the previous problem?
0, 1, 2,
0, 1, 2, 3, 4.
5.
Not 5, just through 4.
4.
So domain is here, and so that means that my range values are what?
5, 4, 3, 2, 1.
Yep, so these are my range values here. There we go. Okay, now that problem's actually done. All right, so I'm going to set up my table. So x, oops. There we go. Okay. So x and y. So x is 0, 1, 2, 3, 4, and 5. So when I plug in 1 for x, what do I get?
Maybe 1 for this one.
Yep, 1 for that one. When I plug in 1,
The next one will be 1.5.
1.5, and that's totally fine to convert them to decimals.
2.
2.
2.5. 3. 3.5.
Yep. So then when I come over here to graph it, it's a little bigger. Then can't even see the grid lines on here. The lighting is weird. Not that. There we go. All right, so x value of 0, y value of 1. X value of 1, y of 1.5. X value of 2, y is 2. X is 3, y is 2.5. X is 4, y is 3. And x is 5, y is 3.5. Any questions on that one? All right. 6. Y equals negative, or not negative, 3x minus 1. Domain 1, 2, 3, 4, and 5. So set up my table. So I want you to, on your own paper, go through and find your x and y values that go together. And then I want you to try to graph them, and then we'll go over it together. And this is one you may want to do increments of 2 on your y-axis because the numbers get kind of big. But if you want to do them out in increments of 1, I don't care.
I finished.
Okay. I'll go over in just a second.
Yeah, I was just thinking. All right, in order going down, what were our range values for each of the domain values? You can just say them. So what is it for x equals 1?
2.
X is 2. Like when x is 2.
5.
Yes, y is 5. When x is 3.
7.
8.
8. When x is 4.
11.
And when x is 5.
14.
14.
So then your graph should look something like this. Just depends on how you scaled it, but should be something along those
Can I have
lines.
your attention, please? Seniors, you will need to be at the youth house at 2 o'clock. Seniors, please do not forget to be don't forget to go to the youth house at 2 o'clock.
All right, any questions on this one? All right, 10 says to write the rule for the function represented by the graph, identify the domain and range of the function. So they give us a graph. That goes to 6 on the x and the y. And the points that are on the graph are at 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So I want to set up my table. So my x and y. So I had a point at 0, 0, at 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. And I need to write an equation that fits that. Yes.
Y equals 0. Like,
So y equals 0 would be the first one, right? Because when x is 0, y is 0. What do we know about them after that?
plus x.
You add.
What do you notice about the x and y values all the way down?
They're the
They're the same.
They're the same. So what does that mean?
Just times it by one.
X equals y or y equals x. Either way, they mean the same thing. So the equation for this one is just y equals x. This one's a simple one. Nothing's being added, subtracted, anything like that. And which values are my domain values? Just tell me x or y.
X.
So ranges.
Y. So
Any questions on that?
no.
That's all the stuff in this section. So your problems are three through 13 odd. So one problem in here is one that you're correcting the error. So you're looking at what they gave you, and you need to fix the error and tell what they did wrong. Some of you on the describe and correct have just said what was wrong and not actually corrected it, or vice versa. Make sure you do both. And then one question is a multiple choice question, so it's like this. And what they do is they've given you the graph, and they want you to say which equation fits that graph. Okay, so you'll just work it like you did this one, and then one of the four options will be the equation that fits it. Okay.